All right. Hi, hello, and happy Law of Cosines. Yesterday we were talking about the Law of Sines, so it's only fair that we talk about the law of my favorite trig function, cosine. In the Law of Sines, we were talking about solving different triangles, specifically angle, angle, side, angle, and side angle. This time, when we're using law of cosines, we're going to be looking at triangles like side, angle, side, where we know two of our sides and the included angle, and our side triangles, where we know all of the sides but none of the angles. Law of cosine is going to be there to help us solve our triangles, find all of the pieces and parts. We're also going to be looking at Heron's formula for area. We talked about yesterday another formula for area using the sine of an angle and the two sides around it, multiplying all of that times 1/2. Heron, an ancient Egyptian, I believe, mathematician, has a really cool formula for area, and we'll be checking that out. And of course, I've mentioned in class that law of sines and law of cosines are two of the most well-used forms of trigonometry in the real world. They're used for mapping out land area, surveying, cartography. They're used a lot in boats and marine things and measuring distance. It's actually kind of cool. Let's check it out. All right, law of cosines. What are they? So if we have any triangle labeled how we've been labeling them with capital A, B, and C at our angles, and across from them having little c, little b, and little a, then the law of cosines are these three variations. But I'll tell you that they're all saying the same thing, just with specifying different sides. Something that I'm noticing is that the side squared on the left hand of the equal sign is the same side that we're taking the cosine of our angle. Everything, all of the other sides are in between, that b squared plus c squared minus 2bc. And it works for the other two variations. I'm able to use any of these, of course. They're really just saying the same thing. Whatever angle or side I'm looking for, I want to be on the end caps. So if I'm looking for an angle, I want to take the cosine of that angle and have the side that I know on the other side of the end cap. Whether I'm looking for an angle A, B, or C, they're all using the same thing. And let's look at it in action. All right. If I want to solve a triangle, specifically in this case a side angle side triangle, first and foremost, we are going to draw our triangle out and we're going to label our angles. I see that the angle C is 25 degrees, our side B is 4, and our side A is 10. Remember that if I'm solving a triangle, I'm looking for all of the pieces and parts. So I'm looking for my angle A, my angle B, and my side C. Something you may have noticed in the law of sines on the other side is that each variation utilized all three of the sides while only utilizing one angle at a time. That tells me that sides are a priority when we're working with the law of cosines. In order for us to find any of the angles, we have to have all of the sides first. So, in order to find angle A and angle B, my first step absolutely has to be to find our side C. I mentioned that we can use any variation of law of cosines as long as it captures what we're looking for. I'm looking for side C, so I want the variation that uses C on the end caps. So that's telling me that my side C squared equals my side A squared plus my side B squared minus 2 times side A times side B times the cosine of that angle C that we are focusing on right now. All right, that's our blueprint that we're working with. Now I get to fill in the values. Our side A is 10, our side B is 4, so I'll fill that in. And our angle at C is 25 degrees. Well, I know 10 squared is 100, 4 squared is 16, negative 2 times 10 times 4 is going to give me a negative 80, cosine 25 still. I'm going to try and combine some like terms, and I'll get that, all right, 10 plus 16 is 116, minus 80 cosine of 25 degrees. I've seen a lot of people today try and separate 116 and 80 and take the difference of them and then multiply times cosine of 25. But which, first of all, is illegal math. What I'm seeing is that 80 is being multiplied times cosine of 25. They are a unit. The only way that I'm able to break up that 80 being multiplied times the cosine of 25 is if I divide it. So I'm not able to take it apart yet, but I am able to throw this whole line into my calculator. That's 116 minus 80 times the cosine of 25 degrees. When in doubt, add an extra set of parentheses. If you are in class, I am looking for these few lines of work so that I know exactly what you put into your calculator. A lot of this is just calculator math, but if you go from the first step to an answer and the answer is wrong, and I can't see any of your numbers, I have no idea where you went wrong. I don't know if you subtracted that 80 minus 16. I don't know if you typed the wrong number somewhere. I need to see your lines of work. But if I throw all of that into a calculator, I'm going to get a result of 43.5. All right, and is that our side C? No, it's not, because I know that all of this was set equal to C squared. In order to find C, what do I have to do? Take the square root, of course. And something I've been asking, we know that a lot of times when we take the square root of things, we have to have a plus or minus, because we don't know, is it going to be positive or negative? But length is always, always positive, right? There's no such thing as a negative length, negative height. So when we're talking in terms of length, we need to make sure that we're always working with positives. Same thing with degrees. We've learned that negative degrees do exist, but not in a triangle, they don't. So if you ever get a negative result for either your side lengths or your angles, you know you did something wrong. All right, I'm gonna let you pause here because I'm gonna have to erase this in order to show how I get one of my angles. Okay, same idea with one of the angles. I get to decide, do I want to find A or B first? I like the letter A, so I'm going to work with A. Since A is the value that I'm solving for, it's going to be the letter that is on our end caps. So little a squared equals little b squared plus little c squared minus 2 little b little c cosine of A. All right. And now I know the side value of B. I know the side value of C. That's 6.6 that we just found. I know everything except for the value of A, which tells me that we are in a good spot because if I should only ever have one variable when working with the law of cosines. Otherwise, we'll never be able to solve anything. So let's plug in some values. I know that the value of A is 10. 10 squared is 100. I know that the value of B is 4. 4 squared is 16. Value of C is 6.6. 6.6 is going to be 43.5 when it's squared, minus 2 times B, that's 4, times 6.6, times the cosine of A, the part that we are looking for. All right, let's clean this up. My first goal is going to be subtracting that 16 and that 43.5 onto the other side. And when I get that, I get 40.5. All right. And on my right side, when I multiply that negative 2, 4, and 6.6, I get negative 52.8 times the cosine of A still. Now, you might be tempted to try and divide both sides by cosine or divide both sides, but we know that cosine is bound to its angle. They're an unbreakable unit, except in the term of taking an inverse of an angle, and that's exactly what we're going to do. But in order to do that, I have to get that cosine of A all by itself, just like when we're solving for any other variable. So I'll divide both sides by that 52.8 to get it all by itself. That leaves me with cosine of A is equal to 40.5 over negative 52.8. From here, I'm going to take the inverse cosine of both of our sides. Reminder of how we get this on a calculator. If you're using a TI, any version of a Texas Instrument, that's going to be second times whatever trig function, in this case it's cosine. And what are we going to be putting in as our inverse cosine? Well, that whole fraction, 40.5 over negative 52.8, is going to all be what I'm taking the inverse cosine of. So make sure that whole fraction is inside of our parentheses. And when I get that, I'm going to get a value that says angle A equals 140 degrees, or 140.1. This is a section in which, depending on how exact you keep your numbers, wherever you round or allow things to be in fractions or keeping them as exact, we might have slightly different decimals. Because if I wait until the very, very end and I keep everything in exact terms and then I allow it to estimate and round up, we're going to have a slightly different decimal trail than someone who takes the decimals at the very beginning. But that's okay. I am looking for mostly the whole number, the process, so all of these steps I care about. And from there, if you got a 140.1 degrees, well, I got 140 degrees even. That is a-okay. And from here, finding angle B, well, I already have two of our angles. If I want to find the third, I know that the sum of the angles of the triangle, I'll add up to 180 degrees. So I can subtract out 140.1, and that's 6.6 from 180 to get a result of 14.9 degrees for B. All right, I'm going to let you pause here. Not too bad, just a lot of math. Okay, Heron's formula for area. We start with our same triangle of ABC. Big A's at our angles, little A's, B's, and C's at our sides. So Heron gave us this new way of finding area when we only have the sides but none of the angles. Our first step is to find something called a semi-perimeter. Now, we've probably heard of perimeters in geometry, or if we've ever tried to build something. Perimeter, we know, is adding all of the outside sides. So in this case, my perimeter would be A plus B plus C for that triangle. Well, we're not using a perimeter, we're using a semi-perimeter. In this case, the semi-perimeter S is that exact perimeter divided by 2. From there, throwing it into Heron's formula, I have this very, very long square root, and my first term is that S, that semi-perimeter we just found. Our second term is our semi-perimeter minus A, one of our sides, times semi-perimeter minus B, another side, times the semi-perimeter minus C, our last side. All 4 of those terms are being multiplied, and then we take the square root of it. So let's look and see. I will also say that this formula is not in your trig cheat sheet, so if you'd like to write it, I would highly recommend it. All right, we want to find the area of a triangle with sides 10, 12, and 14. We don't know anything else, but we do know the sides, and that is enough for us to find area now. Our first step is to find that semi-perimeter. So I'm going to add up all of our sides, 10 plus 12 plus 14, divide by 2. Well, that's going to be 36 in the numerator over 2. And 36 divided by 2 is 18. So we know what our semi-perimeter is. That means that I have enough to at least start my Heron's formula. I have my first term. Our second term, if you remember, is our semi-perimeter minus one of our sides. Now, in the formula, it states A, B, and C. But I know that since they're all being subtracted from the semi-perimeter and then being multiplied, it doesn't really matter which one I use first. So I'll go with 10 because 10 is the smallest number and I'd like to work my way up. So I have 18 minus 10 times 18 minus 12 times 18 minus 14. All right, let's clean it up. I'm going to keep that 18 where it's at. 18 minus 10, 8. 18 minus 12, 6. 18 minus 4, 4. If I multiply all 4 of those numbers under the radical, I'm going to get 3,456, which is huge, but luckily for us, we're still taking the square root of it. From there, when I take the square root of it, that turns out to be 58.8. And a very, very, very important part, it's units squared. I know no one really likes writing out units, especially when it's area and we have to square them. But if I have just a 58.8 and I'm trying to find area, that 58.8 is absolutely meaningless. It has no value to me if I can't tell what our unit of measurement is. And in a case like this, where I'm not given a unit of measurement, I need to say, okay, it's some units and they're being squared. That tells me that this is a form of area, and that's something that I'm very much looking for. So I'm going to let you pause if you need to catch up. Otherwise, I'm going to erase. All right, we've talked about solving a side angle side. Now let's look at a side triangle. Same idea, using the law of cosines. I have triangle ABC, and we don't know any of our angles, but we do know our sides. We know that A is 9, we know that B is 7, and we know that C is 5. We can start with absolutely any of our angles first. I would like to start with A because A is the first letter of the alphabet. So since A is what I'm working with, my form of law of cosines is going to have A on our end caps. A squared equals B squared plus C squared minus 2BC cosine of A. Now I know all of my side values, so I can fill that in. Our A value is 9. 9 squared is 81 equals B squared. Our B value is 7. 7 squared is 49. Plus C squared, 25. Minus 2 times B times C, which is going to get me 70 times the cosine of A. All right. Very, very similar to the last solving with law of cosines that we did, in which I'm going to move everything that I can onto the other side, but still following order of operations. So first, I'd like to subtract that 49 and that 25 from both sides. And when I get that, I'm actually going to have 7 as my result. So 7 equals negative 70 cosine of A. Now I'm getting closer. I can divide both sides by that negative 70. And from here, I can take the inverse cosine of both sides to get the inverse cosine. The inverse cosine of negative 7/10 is equal to my angle A. And if I put that in my calculator, what I'm going to get is that angle A equals 95.7 degrees. So I'm going to throw that into my triangle. I'm also just going to mark it up here. 95.7 degrees. All right, let's check out angle B. Very, very similar as before. I'm going to start with B being on my end caps. So B squared equals A squared plus C squared minus 2AC times the cosine of B. All right, let's fill in what we know. I know that the value of B is 7. So B squared is going to be 49. A squared is 9. So 9 squared is going to be 81. Plus C squared, 25. Minus 2 times 9 times 5, which is going to be 90 times the cosine of B. All right. From here, same as before, let's subtract that 81 and 25 from both sides. right. A lot of this section is just calculator work. Now see, when I solved it earlier, I found the angle of C instead, so I just have a little second of calculations. So that negative 57 equals negative 90, cosine of phi, same thing as before, and I would like to divide that negative 90 from both sides. And I can take the inverse cosine and say, okay, the inverse cosine of that negative 57 over negative 90, you know a negative over a negative is positive, is going to equal my angle B. And when I put that into my calculator, I get, perfect, 50.7 degrees. All right. And if I want to find C, all I have to do is subtract our angle A and our angle B from 180 degrees, and I would get that angle C equals 33.6 degrees. All right, not too bad at all. Trig-wise, it's very, very similar to the law of sines, but with a lot of extra algebra and calculator work. All right, that's all. Thanks for having fun with trig.